Yeah, thank you. Wow, last talk before the break in the morning. I'll try to entertain you with a little new idea. I'm new in all of this area of transparency and key transparency. I started working on it roughly a year ago. I found it super exciting. So you will probably see me sticking around for a few more years. I also have a PhD student on this topic, so at least 4 years are going to go in this direction. What else? I'm an assistant professor at Chalmers University here in Gothenburg. So if you like this wonderful environment, you can come back and contact me anytime with question about this topic and other things in cryptography. So I want to tell you something about transparency. Like, how do we introduce transparency? How do we ensure consistency of the way that people the tree hash they received or the view of the keys in my KT log? And I want to pickle an idea that is building on what has been suggested during the previous talks. So we have seen like auditors out there, we have seen like clients trying to audit each other, and I am just suggesting a twist to this through anonymous committees. So just to put a little bit of a framework, bear with me, I am a academic, so I like to have like good names, good frameworks, good systems. So this is clearly a log. I'm not going to say what the log is, but actually it's nice to have a proper definition of a log, and a transparency log is not exactly a log, it's a log with additional properties. But at a high level, we're going to have submitters, so some people that are putting things in the log. We're going to have advocates, so somebody who is checking the quality of the log. And we talk about append only a lot, but I think in general I could have a growth policy, an evolution policy, and I want that these advocates will check that the log is evolving as it's supposed to. For instance, that the keys are updated as supposed to, or that is append only. And if they think that this is indeed happening, then they can maybe sign. And then people, consumers that are consuming the log can download and see, okay, I collect enough signatures, that's good enough, or there are signatures of the people that I want to be there, so I'm happy. And I want to clarify there are two kind of type of consumers of the log. There are the direct consumers that actually talk to the log and download from the log, I don't know, the latest hash tree and all the signatures or the whole tree and whatnot. But everything is publicly verifiable. We don't have any designated verifier, we don't have any secrets. So they can broadcast what they got to a lot of indirect consumers that don't need to talk to the log, but can benefit of all the transparency guarantees of the log. Okay, so let's see a little bit of an example with the SIGSAM by Glasklar and the witness co-signing paradigm. So what happens over there is like advocates are basically providing their digital signatures, and consumers will, this digital signature will go to the log, and direct consumers download this from the log, and then they will check. Do all the signature verify for the same view of the log? Then it means that I have 4 advocates saying, yes, we agree that this is the view of the log, and the probability that the log has been corrupting all of these keys is low, so I can be sure that there is a consistent view. Everybody who is downloading the current view of the log will see the same things as I've seen. But there are cases where maybe, does this actually point to something? No. I don't get a witness signature. What do I do there? The witness is offline. Or maybe a signature doesn't verify. What should I do in that case? How can I make sure that there is no split view happening? And on top of this, there are still 2 issues, I think, with this witness co-signing paradigm. One is that witnesses are fixed and known. So I know that there are 12 witnesses out there. If I am a state-level adversary, I can just target to corrupt precisely these 12. Yes, it's expensive, but it's a finite amount. And once I target them for corruption, I can make them sign more than 1 tree head, which is what they were supposed to do if they were honest. But now if I sign 2 tree heads, then I can convince Alice that her key has not changed, and Bob that Alice's key is different. And second, to prevent split view attack, one needs to verify actually kind of many signatures, because you want to make sure that if Alice and Bob have the same view, this is ensured as long as they check 1 signature of 1 honest party, the same honest party, not different ones. So there needs to be a sort of overlap that has been mentioned also by other people. And the formula we got so far is like basically you should check a quorum, many signatures, and they should be roughly half of all the existing signers out there. If every user does this, every consumer does it, then you're sure there is no split view attack, and it's more than half if you need to count for there being malicious parties or silent user advocates. So it's not as little as you think. Of course, you can check all the signatures in the worst case, and that works. But here it comes a bit my idea. So I have a log. If you think about key transparency, like I have a bunch of users, everybody's using the log for the communication messaging and storing the key in the key. So I will upload if I'm doing some updates of my keys. And then I don't want to have an external set of fixed users. Can I use the same user pool of the log to do the advocating? Check that the log is actually not delivering split views. So the idea is like, yes, we can run a cryptographic lottery. And this is basically like having a coin, flipping it, and then seeing, am I being selected or not? This is a verifiable random function, has been mentioned before. If you don't know what it is, think of a signature, unique signature for a message. If your signature is small enough, you're in the committee. If not, you're not selected. There are a bunch of things I'm hiding under the carpet, like you need to be secure under malicious key generation and whatnot, but I think this is not for the audience. So I have a cryptographic mechanism to randomly select people. Now, these are going to be the advocates. These are going to be the people that will actually check the log is growing correctly. And if it's growing correctly, they will deliver their keys, their signatures. And these shouldn't be just standard signature. We probably need to have a key evolution so that in case I'm corrupted after I reveal my key has already evolved. So you can no longer use the previous key to sign a split view. And then everybody that is active should monitor. So it's just a new paradigm. And I think there are a few positive sides. So that we remove the trust from a small group of designated witness to all the logs, all the clients that are actually using the log. We avoid gossip, which we know doesn't scale well with the large population, like the billions of users in WhatsApp. And it does not require peer-to-peer out-of-band channels. So this is particularly relevant for KT, as it's already been mentioned in the previous talks. It works best with many clients. The more clients we have, the smaller the portion of the committee we need to have. But it requires to do more work and more signatures than witness cosigning checking. So this is still a work in progress. If you're interested, this is the ePrint paper. So happy to get feedback and questions now or in the break. Thank you.
Questions or feedback? Yes.
Hi, thank you for the talk. Correct me if I'm wrong. This looks like some kind of distributed consensus protocol. And as far as I know, it has been solved already several times. For example, by Tor directories, their approach is some designated witnesses. And despite all the state actors, Tor has been holding up pretty well. And on the other way, something with a cryptographic lottery that has like a stake, witnesses, and strangers trying to verify the consensus is something like the Ethereum blockchain that has a proof of stake with a lottery. Have you looked into these models or?
So I have not looked specifically into Tor, but Ethereum, yes. But there is a, big difference between blockchain kind of things and transparency kind of things. So consensus, you achieve it by having a resource that is hard to replicate. Make it be proof of work for Bitcoin, make it be your stake that you're putting in the proof of stake. Here we don't exactly have a resource that is hard to duplicate. You're just assigning. So it's, in a sense, it's way more efficient than anything you can create with blockchain-like things. And yes, there is also a Byzantine fault tolerance agreement. Like there are a lot of ideas out there. I'm just trying to do something that is efficient and fits the overall working of the log. But thank you for the pointers.
Thank you for the talk. This may be a naive question that I missed. Is like, what's preventing the service provider from just choosing or creating the witness that just agrees with the corruption?
So the fact that you're using a verifiable random function, so like a cryptographic verifiable random function, it's a coin that tells if you are in the committee or not, cannot be biased.
So that is the code that runs on a client, is that correct?
Yes.
Okay, so assuming that construct will have to be like open source for audit, not like the service provider can just not run that function.
Yeah, but then in the moment in which I am providing like my witness signature, I also need to provide a proof that I have been selected in the committee. And then people will see, okay, this is a publicly verifiable proof. It doesn't work, you were not there. So we have thought about that.
Thank you for the talk. I was wondering how you square the idea of, so some KT implementations have witnesses that have to do quite a lot of work because proofs get quite large, and these witnesses are stateful. They carry a copy of the tree, which is again quite large, and then apply updates very quickly as they stream in. How do you imagine clients, like somebody on their phone, doing something similar in a short period of time, depending on how frequent rounds are, and also in the face of people coming online and then going immediately offline, but being elected possibly for verification in that time?
Okay, so I split the question into two: how to do with like offline users, and then you can just model saying, okay, the probability of selecting a user is a binomial distribution, and I have a portion of people who are offline, so there is a way to handle with that. The other question, it's very relevant. I admit I am a mathematician, I'm an academic, so I just thought, okay, the log works, there is a way to check it efficiently, but I'm realizing that's not the case. But the twist I would do is like, instead of necessarily having the users, I can just increase my pool of witnesses. So instead of having just 100 people, I can actually have like thousands of people. So you can have a small threshold to become a witness, just enough to make sure that not only malicious witness will sign up to this doing the job, but then you know as a witness that you will only act, I don't know, every 5 epochs to do the actual hard work.
Gotcha. Thank you.
Thanks for the talk. You mentioned that you need some barrier for, preventing just malicious witnesses for showing up, but this seems like it assumes either some sort of, like was sort of discussed before, like stake or identity or something to prevent, just fabricating, twice the number of malicious witnesses as there are like honest witnesses. Do you have like ideas how this would work in like a open messaging application? Yep.
Very good point. I think Melissa already mentioned that we kind of rely on there being an identity provider that says these are all different people. And in messaging, it's very easy. You all have different phone numbers.
Yeah, but those are not like publicly verifiable, right? I mean, like the only people in Signal who know that they're real phone numbers behind an arbitrary person are the operator and like possibly their contacts, right?
Yeah, but it's still already a check that is doable. Another way is like, okay, maybe this doesn't scale to KT for messaging per se, but it would work, for instance, in Sweden, where the amount of social security number is something you can trust from the state. So I don't need to know whose social security number relates to whom, although that's fairly easy to know in Sweden, sadly. Like then you can check up where I live and the average of my salary just on a hitta.se with my name. I'm the only one with this name in Sweden. But okay, what I'm saying is like there are ways to get like a public list. I'm saying this is the amount of people. There is no more than this. All I need to know is the total number of users, and then I can make an assumption saying, okay, I want to tolerate a third bad parties, just 0.2 or not.
Yeah, thank you.
But it's not bulletproof, I agree. We need to rely on something, but that's the way we can do it more efficiently than blockchains. Otherwise, you need to have a resource that is hard to reproduce.
No, that was the question.
It is a very valid question, absolutely. Yep.
Can you tell us about how big the proof is that has to be shared about I have won the lottery?
That is literally just a signature. Basically a signature, so like a group element.
Okay, so it would roughly double the size of what we currently have.
So you have like one group element. It depends on which implementation of the verifiable random function, but like we have a proof of concept implementation done by a master student, so it might explode in your hands. But so like the cryptographic lottery is one group element, and the key evolving signature, that's basically the pre-image of a hash. and a little bit more just because you are evolving your key, so you need to kind of give, okay, now the next key that I'm gonna use is this one, and the previous key is invalid because I used it once.
Okay, and also the association of the lottery happens like per log checkpoint. Roughly.
Per epoch, yeah. Yeah. Log checkpoint.
And associating those is just clear enough.
Yeah, so like you can use like the tree hash as an input to your random thing.
Yeah.
And then it's like if you think that the log can actually cheat with that, you can also try to get an external source of randomness, a beacon, and say, okay, these two things at this time, I cannot bias it. And that's why we are sure that you cannot skew too much on selecting only the bad guys that are within my population.
Thank you.
Thank you.